Hello dear students, today I am going to discuss some of the problems that I have uploaded. In fact, I am going to discuss in some detail two exercises. I hope you have watched the videos on distribution function, probability distribution, and look at the note. So now you may be having some doubts, but let us try to, these exercises will probably help you to clear your doubts. So I have defined a function like this, which is 0 for y negative, and between 0 and 1 it is a straight line joining 0 0 and 1, and at 1 and beyond it is 1. So you can imagine what kind of function is that. This is a continuous function increasing from left to right. So I have asked whether this is a distribution function. So what you actually have to verify is that whether it satisfies the properties of the distribution function. So you see that since this is a function increasing from left to right, the minimum value is 0 and the maximum value is 1, and everything between is fractional. So therefore it is a mapping from the real line to the interval 0 1, closed interval 0 1. And so the first property is satisfied, and it is non-decreasing. It is obvious from the sketch of the function. Still, if you want a formal proof, you can see the values, right? If you take two numbers a and b, if a and b are both, one is negative, a is negative, b is positive, then obviously it is trivial. If a is negative and b is above 1, then also it is trivial. Only when it is between a and b are both between 0 and 1, and you see a is less than b, then what happens? Then you see the difference f of b minus a, f of a is b minus a, which is in fact the length b minus a. Therefore this is a non-decreasing function, and this is a continuous function, so right continuity is also taken care of. And f minus infinity is 0, because since f minus n will be 0 for every n, and f n will be 1 for n greater than equal to 1. So f minus infinity 0, f plus infinity 1. So it is a function with range close interval 0 1, continuous, non-decreasing from left to right. So it is a distribution function, and in fact f is a continuous distribution function. Therefore we will call the corresponding probability distribution to be a continuous distribution. So if x is a random variable with this particular distribution, it is a continuous distribution, and in fact this distribution has a name in probability and statistics. It's a famous distribution called the uniform distribution on 0 1. Now it has special relevance, as I just mentioned, that if I take two numbers a and b between 0 and 1, a less than b, then what is probability x greater than equal to a less than b? That is something we have argued in our lectures related to distribution function. Then this probability is f of b minus f of a, where fy is the distribution function of x. So now by the formula given in exercise 1, this turns out to be b minus a. Now this is length. So this distribution is actually the Lebesgue measure on the collection of Borel sets on 0 1. The Lebesgue measure restricted to Borel subsets of 0 1, that is the uniform distribution. So now if I look at the so this example is clear. If I give you a formula and ask you to whether it is a distribution function, you actually you have been asked to verify the properties like right continuity, non-decreasing property, f minus infinity 0 1, and so on. Now then in exercise 2, I have given you a discrete random variable, and I have told you this is a simple random variable whose name is Bernoulli random variable, or it is said to follow Bernoulli distribution. So I have written that x follows Bernoulli half. That means x takes both 0 and 1 with the same probability 1. I have asked you to compute the distribution function. So now let us see how do I compute this distribution function. So distribution function means what? Probability x less than equal to y. That was the definition of a distribution function of a random variable. So then you see, since x is taking two values only, 0 and 1, the range of x in this case, range of x, what is the range? It is not the 0 1 interval, but more specific. It is the set consisting of only two elements, 0 and 1. So if you give me anything negative, x cannot take any value. So that is an empty set. So this will be 0. Empty means in what sense? That there are no points in the domain of x for which xw is negative. So it is so that collection is 5, and so therefore this is 0. And if you ask me then what is probability x less than equal to 0? Well, why it cannot be negative, but surely it can take the value 0. So this event is same as asking probability x equal to 0. So this is half. Now if you give me any y between 0 and 1, then say y equal to 0.5. Well, then x cannot take 0.5, x takes only two values 0 and 1. So anything between it will take only the value 0. So this is half. So you see y is for negative y, fy is 0. For y between 0 and 1 it is always half. And so it will jump up to half at the point 0. This fy, f0 is 0, and your fy for y between 0 and 1 remains half. But at 1, what happens at f1? What is the value of f1? So for 1, f1 will be probability x less than equal to 1. So x is taking the value only two values 0 and 1. So that will be same as probably either x equal to 0 or x equal to 1. So therefore it is half plus half 1. And for above 1, so if you ask me what is probability x less than equal to 2, oh, of course below 2 there are all the values of x. So therefore it is 1. So you see what kind of function is this? Is this a continuous function? No, because if you imagine the plot of this function, for negative y it is 0. At 0 there is a jump at half. So there the continuity is breaking. Then from 0 to 1 it is continuous half. It is a straight line at parallel to the x-axis, height is half. But what is f1? Again there is a jump. It is from half, it is jumping up to 1. So it is like a staircase increasing from left to right. So it is called a step function. So in fact for all simple random variables the distribution function will be like this, a step function. And the step function, the height of each staircase will be the probabilities of those values. Remember, I had asked you an exercise. Recall, I had asked you that can you see that f of y minus f of y minus. What is the meaning of f of y minus? I will tell you. Is x equal to y. So f of y minus is probability x less than y. Now this is also requires a proof, and here you can see an application of continuity theorem that I will discuss. But the point is that f of y is probability x less than equal to y, and here it is strictly less than y. So you see what is the difference? It will come by addition theorem, because a probability x less than equal to y can be split as two disjoint events. One event being that x is less than y, and the other event is that probability x equal to y. So the sum of these two probabilities is fy. Therefore you have this. And so the point is that in this case, what is a probability x equal to 0? It is this difference. You see f0 is half, but the left limit at 0 is how much? That is 0, right? Because fy is 0 for every y negative. So the left limit f0 minus is 0. So this difference is half. So the point that I am making is, if the distribution function has a discontinuity at y, then the difference between fy and the left limit is the probability. So here the staircase is taking a jump. The jump height is the probability. Okay. So now coming to the third exercise. So coming to the third exercise, so I have asked you to compute the 50th percentile of this Bernoulli distribution. So 50th percentile means you are to, in exercise 3, exercise 3. In exercise 3, so let me make it 14. In exercise 3, I am asking you to compute QP. QP for, so I am asking you to compute QP for P equal to 0.5. So 0.5 mane hol 50 percentile or the median. Yeah, so I could also ask to compute the median. So what you need to find? Remember, the distribution function is a function that is in non-decreasing from left to right, and it is increasing from 0 to 1. So if you give me any proper fractions and look at the values of fy, so fy will definitely go up above p for some value of y, right? Otherwise it cannot go up to 1. If fy is less than equal to p for some p between 0 to 1, then fy can never go, then this property that f infinity 1 will be violated. Then f infinity will be equal to that p. So therefore, whatever be p, 0.5, 0.9, 0.99, so there will be always at least one y, where fy will either attain that value or exceed it. So your job is to find that value. So you are to find infimum of y where fy has exceeded or it attained, so greater than equal to 0.5 for the first time in exercise 2. Now is that very difficult? Once you have done the distribution function, you see f0 is half. So you don't need to look any further, because beyond y it cannot go down. It is a non-decreasing function. So therefore QP will be equal to so QP will be 0. So so in exercise 2, therefore QP will be equal to 0 for p equal to 0.5. Okay, so can you tell me now what will be Q 0.75? So if I make p equal to 0.75, then what will happen? Can you tell me? So this is slightly trickier. I am leaving it for you. And now I go to example 4. Okay. Now in my laptop, this is a very old version, so this docx file is not opening. What was it I had given? Okay, I remembered. So here in exercise 4, I had defined fy to be equal to 0 for y negative and fy equal to fy equal to 1 minus exp of minus y for y greater than equal to 0. Okay, I think so. Yeah, in any case, please have a look at this one. So my question is this again a distribution function, and then is it a discrete or a continuous distribution? This is a much easier exercise. So you see, this is exponential distribution, so it is continuous. There is no way it can be discrete. Now only you need to look at 0. So if I take y tends to 0 from the right, then this will be going to 0, and so therefore this is your continuous function. And is it what is f minus infinity? Obviously 0, because f of minus n is 0. What is f plus infinity? That is 1. You will take y tends to infinity. And is it a non-decreasing function? Yes, because as you increase y, so you see, for any positive y, 1 minus exponential minus y is between 0 and 1, right? So it is 0, 1 valued, and as you make y larger, this will go closer to 1. So therefore this is a non-decreasing continuous function increasing from 0 to 1. But the main difference from here and the uniform distribution, do you see one? Do you see the difference? That can you find a y for which fy is exactly equal to 1 in this exercise 4? No.